Welcome to myprojectbazaar.com. Let we discuss about the process, a novel image registration algorithm for remote sensing under affine transformation. Let me see the abstract of the process. Satellite images are collected from different sensors. The image pixel values and the objects located in the pixels were different in reference and the target images. The reference images has mainly intensity variations and object location difference. The registration process transforms the target image as the reference image, which helps in the remote sensing process. The input reference image and sensed image are preprocessed by applying Gaussian filter. The feature points are extracted from the preprocessed images using shift algorithm. The feature points refers to the location of the image pixels present in the images that have the same coordinate values in different orientations. The extracted feature points were the same for different images. Correspondence is established between features between the the sensed features in the sensed and the reference images. The correspondence process refers to the matching of the pixels. The reference and the the target regions were clustered. The clustered process is employed in both target and reference image. The clustered portions in both the reference and the target portions which are in common were identified. The identification of the correct matching pixels will give the pixels that are needed to be modified in the sensed images. The sensed images is transformed similar to the target image by piecewise transformation of the pixels from the sensed images to the reference images is employed. The performance of the process is measured by accuracy and error rate. The error rate gives the rate of number of pixels modified in the sensed image corresponding to the target image. The error rate is the rate of number of pixels modified in the sensed images corresponding to the target images. The proposed method has overcome the difficulties in existing complex HSTC and other methods, and accuracy is also improved in the proposed process. Let me see the flow of the process. The reference images and the sensed images were taken. The reference image is initially preprocessed and the sensed images were also preprocessed. After preprocessing, the shift features were extracted from both of the images. The matching key points were selected. So this process is the feature matching process. As the result of the shift descriptors, the most important edge regions in the overall images were obtained. The obtained image pixels were then compared and the matching is done. The comparison is checked by analyzing the x and y coordinates of the extracted key points in both of the coefficients. The identified regions were then selected from the images and the images were undergone transformation. For in transformation, actually the pixels were clustered using fuzzy C-means clustering. The fuzzy C-means clustering process clusters the images into different regions based on different intensities available in the images. So each intensities were analyzed and they were obtained. After that, the clustered regions were used for the comparison of the selected features in the images. So the clustered regions were picked from the analyzed key points, and after that the key points were matched, and based on that the image pixels were obtained. So if the matching portions and the key points were matching means then the pixels from the reference images were selected, or else the pixels from the target images were selected. So by comparing these two, the pixels registered portion of the input images is obtained. After the identification of the registered portion, the performance measures of the processes were employed. The overall performances of the process is measured in terms of accuracy and error rate. So the accuracy is measured by calculating the mean square error and the peak signal to noise ratio. So the obtained mean square error is the error rate, and the accuracy is obtained by subtracting it from 100, so that we get the overall accuracy for 100 percentage. Thus we have calculated the overall performances of the process, and the reference and the target images were compared, and based on that the registered images were obtained. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. The process will get started. First, the browsing option will appear, and we have to select any one of the reference images. So we select this reference image. After the selection of the reference image, the image will be displayed, and after that the pre-processed image will be displayed. So after that, this is the reference key points, and we select the target images. So these are all the reference images key points, and this is the input target image, and this is the target image key points. At each instant, the number of key points selected and the time taken were measured, and they were displayed. So this is the target image key points. Then after that, the clustering process will take place. So while clustering, the clustering process will take place in iterations, and in each iterations the trusted portions were got. So as we can see, this is the registered portion in the reference image. So these portions were selected for registration in the references first. This is the clustered image obtained. This is the reference image cluster, and this is the target image cluster. So this is the final result that we got. So this is the reference image cluster and the target image cluster. The clusters of the references images were depicted separately. Similarly, the clusters of the references were depicted separately, and after that the pixels were selected in both registered and the target portions. So as we can see, these are the selected portions in both registered and the target locations. The triangularization process selects the pixels that are needed for the processes, and after that this is the reference image, and this is the target image, and this is the registered portion. So the registered portion is similar to the reference images that we have got, and we have measured the overall PSNR, RMSE, and the overall accuracy value of the process. The matching percentage were all being calculated, and the results were displayed. Thus we have analyzed the registration process by comparing two remote sensing images. We have selected two remote sensing images. The images were registered by clustering and selecting the related portions in both of the images and placing. Thus the registered image is most relevant to the target images that we have, reference images that we have given. Thank you.